While we're waiting for the library to download to the IDE, let's take a look at some of the things that are actually on this board and some of the things that we'll be controlling. So the board, as hopefully you've already done by now, just sits right into a breadboard. And these pins along here all have different functions. So here's the board actually plugged into a breadboard, and then I also have this PDF here that shows what each of these pins are. So looking at this, the way that they're kind of laid out, we've got a couple built-in LEDs that you should have already noticed, like when you first, whenever you apply power through the USB, you should see this light here turn on. This is also can be it's also referenced as a constant in the software. We'll talk about that in a video or two. This up here is another LED. This is one that you can control programmatically. It doesn't turn on automatically, but it's a good thing to have there. This is a reset button right here, so it's a nice clicky tactile button. So this is something that you can press to restart your sketch while it's running. You don't need to re-upload anything. You just press that once, and whatever you have on there stored will just go again. The rest of the board is populated with, this is the main processor as well as the radio for Bluetooth communication. All the other chips on here are supporting this, essentially. Some of them handle communication protocols, other are capacitors to help talk to the pins. Others have other kinds of specialty functions, but that's really what everything else on this board is for. It's just to support this communicating to this. The pins on here, as you can see, there's the things that we're most concerned about for our purposes are these things that start with D, ground, reset, and then these power ones. So let's start with power first. That's always going to be your most important concern. So we've got ground, which are the pins that are labeled with a little stripe of white paint. And so remember, in a circuit, everything needs to go to ground, which is why you've got two of these. They're really important. You also have something right here for, it's called V in. So this will give you whatever voltage you get coming in off of this. By default on USB, it's 5 volts. So you get 5 volts out of there. You also have up here a 5-volt pin. This will supply 5 volts to anything connected on that. And then up here, the one that we've got wired up is 3.3 volts. These pins on here in this processor, they run at 3.3 volts. So you never want to use that 5 volt or the VN pin. Those are really useful for controlling motors or other components or things that run at a higher voltage. But since these pins are rated for 3 volts, you don't want to apply voltage through a switch or a sensor or something like that using these. So you'll always want to keep power everything off of this pin right here. Now these other pins, the ones that are labeled with D or A in this PDF, they are, so like this here and these along here. Oh, it's terrible. Or these, or, these are all your digital and analog pins. These are the pins that you can configure to be either an input or an output. And this week what we'll be doing is we'll be talking about configuring these pins as digital inputs or digital outputs. So that means that either they can read the voltage that's applied to them and determine whether it's above a threshold and therefore it's on, or below that threshold and it's off, or we can write voltage out to them. So we can either write out 3.3 volts or we could write out 0 volts, which effectively is pulling something to ground. And the pins that we want to use here are the ones that are labeled D2. All right, so you can see here D2 up through D12. So it's pretty much this whole side of pins, this whole row right here. And then D13, which is this one up here. These are all your digital pins, and these are the ones that can be configured for digital input, digital output. And that's what we'll be using for reading switches, for turning lights on. Later on, if you want to use them to control motors or things like that, you can use those pins too. Pins 0, D0, D1, those are down here, and these are also, you can see, referred to as RX and TX. These are specialty pins that are reserved for communication protocols. So that's receive and transmit. And that's how one of these chips here actually speaks to your computer, is via the receive and transmit pins. So we don't want to put any components on there. Instead, what we'll be doing is we'll be using pins 2, 3, 4, 5, etc. up through 12. Those are the ones that we'll be using this week. Next week, we will talk about these analog pins here, and then we'll also talk a little bit about what these little squiggly tildes mean. But for the time being, we're just going to focus on these here, the ones that are just labeled D. The nice thing about this too is this is also how we reference these inside of our code. So if you are talking to pin 2, you know that you're speaking to this one, pin 3, pin 4, pin 5, etc. These other numbers on here, these are the numbers that are internal to the microcontroller. They're ports. If you ever want to go and code lower level C or C++, that's how you would reference these. But the Arduino IDE and software really make it easy and abstract a lot of the low-level gunk that a lot of embedded developers typically deal with. So we can just refer to these as pins 2, 3, 4, 5, 6, 7, 12, whatever. So yes, that's our crash course introduction to these things. Remember, 3.3 volts, ground. You want to have those wired up, as we discussed in the videos last week, like this. And we'll primarily be using these pins along here this week for digital input and output.